Hi students, so today we are starting off with our journey of modern physics, and the first topic that we are going to do is atomic structure. Alright, so let me just quickly introduce myself for all of you who are watching me for the first time on the JEE English channel. My name is Sumit Kundu. I'm a BTech graduate from IIT Bombay, and it gives me a great pride to say that I had a rank of 2125 way back in the year 2003. All right, I passed out in 2007, and for a brief span, I was into the corporate sector, had my own business, which was acquired by Naukri.com in 2011. And since then, I have been teaching, training, and guiding students to reach out to their dreams and aspirations. So, let me get started off with something very important, that is your tinyurl.com/JEE mobile. Students, try and understand under the current circumstances that we have in the country, and yesterday you must have also watched Namoser's video live, okay, on the current situation and how things are going to be. Will the lockdown kind of stop by the 21 days, or is it going to extend? So you'll get all your answers in that particular video. Okay, so what we are assuming that maybe it will get extended, but yes, we cannot make any comments on that. But we know for sure what has happened is your JEE mains has been postponed, right? So in case your JEE mains has been postponed and you would want to do any particular topic in great depth and detail, which you might have ignored, which you might have kept, fine. So this is like one topic I don't want to do. But yes, really gear up, students, okay? Because I will tell you that extra, because try and understand your competition has actually increased, because all the other students who are also preparing for the JEE mains, they'll be doing the same, isn't it? So why should you be left behind? And since all of you are locked down, you cannot go to your coaching institutes or to your favorite coaching sir in your city or in your town. So I suggest that you should refer to tinyurl.com/JEE mobile. Now here, what do we have? It's like a video book. Okay, it's like a video book where you will have all the lectures. Okay, if you see here, you will have the physics, chemistry, mathematics of 11th standard, and you have the physics, chemistry, mathematics of 12th standard. So any topic from these chapters, all right, you can easily cover up on the remaining days. Fine. Now, something which you would also want to consider while it is a lockdown scenario in the country, and that is the subscription, that is the plus subscription, right? Now, what exactly is the plus subscription? Now, regarding the features of the plus subscription, I'm going to tell you towards the end of our today's session, but let me just tell you the prices right now. See, let me tell you something, that these tinyurl.com/JEE mobile, it is absolutely free of cost. Okay, so when an academy is offering something which is absolutely free of cost, and it has got a tremendous value, that it is like, you know, all the physics, chemistry, maths lectures are like free out there. Okay, so you can well imagine that if something is being priced, that means if something is being given to you for a price, the amount of value that this particular product must be having, isn't it? So let me give you just a small brief. I tell all my students it is like the Netflix, all right, of education. You get a variety of courses, variety of top educators. So let's say you do not understand how a particular educator would teach, you can go and attend the sessions of another educator. Okay, so you might understand, let's say, mechanics well from one, so probably the other educator will be able to explain to you the electrodynamics better. All right, so it is totally upon your choice. It is just like visiting a university where different topics have got different lecturers, isn't it? Even within the same subject, different topics have got different lecturers. So you can use that liberty. Not just your IIT JEE training, okay? Because there are certain faculties, certain educators who would also want to take up, let's say, launch a KVPY course for a month. So you can go ahead and attend all the sessions of the KVPY, where in India, we are all aware that we don't have any formal training for the KVPY. But we know that it is a very good opportunity for the students to earn a scholarship, all right, and that is till their doctorate level. And it is also not just the scholarship. If you even leave the scholarship apart, all right, as some of your students would be doing your 12th standard, all right, As some of you would be doing your 12th standard, the 11th standard gets neglected. So you get a revision of it while you're attending these sessions. And the level of the questions in the KVPY, you know that they are of JEE Advanced, right? So automatically you have JEE Advanced being taken care of, you have JEE Mains being taken care of, and along with that, the KVPY. So with just one course, you are covering like 3 different examinations, isn't it? So it is of super immense valuable thing, all right? And let me tell you that the prices for 2 years, that is for 24 months, it comes to how much? 36,000. And for 1 year, it comes to 30,000. But there's a good news. Using the code SMLIVE, all right, you will right away get the maximum possible discount while the time of payment comes, and you will have to pay only what? 27,000 per month. And here for 2 years, you have to only pay 32,400. Let me tell you, if you do the calculations like, per month, okay, it comes to somewhere around 1350. And if you do it like per day, it comes to like 50 rupees. Now tell me, what is the value of like 50 rupees? We just spent 50 rupees maybe on like a mocha shake or something, isn't it? So something of so much of value is coming to you for such a minimal price. So while you're in the lockdown state, you must consider getting a plus subscription, and that too using the code SMLIVE. Chalo bacho, let's go ahead to our first question for our today's session. Now, this is a question based on the wordplay, all right? That is the wordplay of English out here. Some students, they definitely get confused with this particular question and they end up giving the wrong answer. And that wrong answer is also one of the options out here. So they actually test you on your psychology. And I have seen whenever I have taken this question on a poll, there is at least 40 to 50% people who have given me the wrong answer. All right. Now, what is the question? Let me just have a look. See, there is an electron which, since I have drawn the diagram for you, you know it very well. But sometimes when people read it like, the electron jumps initially from the third excited state to the second excited state, they take the value of the initial n to be equals to 3 and the final n to be equals to 2, and then from 2 to 1. But this is just the play of the words because they want to take advantage of your mental situation during the time of stress of the examination. All right. Dekho, simple si baat hai. Now here, when I am talking about the third excited state, what is the first excited state? This is what? This is my ground state. So for ground state, n is equal to 1. For the first excited state, n is equals to 2. For the second excited state, n is equals to 3. And for the third excited state, the value of n is actually equal to 4. All right. Now, what are they saying? That it jumps from the third. That means it jumps from 4 to 3 and then from 3 to 1. All right. See, when it is jumping from a higher state to a lower state, it is going to radiate some wavelength. Okay, so there is going to be some kind of an emission, and that emission will have a particular wavelength. So say that wavelength is equal to lambda 1. Okay, and then in the second emission, because it is coming from a higher, see, if it goes from lower to higher, it is going to absorb energy. When it is coming from higher to lower, it is going to give out energy, isn't it? So it is basically coming from a higher to lower, so it is having an emission, and this emission has got a particular value of wavelength, that is lambda 1, and this one has got lambda 2. They have asked us to find out what is the ratio of lambda 1 by lambda 2. The question is very simple. How do you do it? Okay, we will use this particular formula, that is 1 divided by lambda is equals to rz square into 1 by n1 square minus 1 by n2 square. We know exactly what is the value of your n1 and n2. See, for lambda 1, it is from 4 to 3. All right, so we'll take the value of n1 as equals to 3 and n2 is equals to 4. Okay, and put it into this equation that we have here. Rz square. See, now it is a hydrogen atom, isn't it? So for a hydrogen atom, the value of Z is equals to 1. So it actually does not matter whether I keep it as 1 or just write it as R into 1 by 3 square, that is 9. All right, so 1 divided by 9 minus 1 divided by 16. See, these calculations are not very difficult. All right, so when you solve it, 1 divided by lambda 1 will give you what? Rz square. And when you take 9 into 16 as the LCM, you will get in the numerator 16 minus 9. So 16 minus 9 will be equal to 7. That is very simple enough. Now let's go ahead and find out what is lambda 2. 1 divided by lambda 2 as per this equation will be Rz square. Now the second jump is from 3 to 2. All right, so I write here 1 by 2 square minus 1 by 3 square. So if I put down the values here, 1 by 2 square, 1 by 4 minus 1 by 9. Similarly, I'll take 4 into 9 as the LCM, and I'll get 9 minus 4, that is equal to 5 in the numerator. Okay. Now, when I have 1 by lambda 1, so we are taking down the results out here. See, the question is very simple now. Okay. RZ square 7 divided by 9 into 16. We got that. Okay. We also got 1 divided by lambda 2. What has been asked to us? To find out lambda 1 divided by lambda 2. Alright. So for finding out lambda 1 by lambda 2, we'll divide equation number 2 by equation number 1. So what we get, lambda 1 by lambda 2 is equals to 20 divided by 7, because 9 and 9 is going to cancel out. 4 is going to cancel this by 4 times, and we are dividing this equation by this equation. So it comes to 20 divided by 7. So you can just try it out on your own as well. Alright, students, if you have liked this particular solution, go ahead and press on the like button. And yeah, go ahead, share it as much as possible. Alright, let's have a look at our second question. So I have got a set of like 10 questions for today's session. So we'll try to cover them up within a span of your next 1 hour. Okay. So what do we have here? See, let us try and understand these questions. Once we understand the questions, all right. See, 40% of the problem solving, there are different stages of problem solving, right? Like, there are different stages of the growth of, let's say, a butterfly. You have studied in the younger stages. So there are different stages of problem solving also. So the first stage, which is like, the comprehension of the question, is very, very important. And sometimes in the stress of the examinations of your JEE mains, you do not tend to absorb the question well. And that becomes a big problem. Okay. So I would suggest in your practice time, all right, in your practice time, you must just try to read questions and just like a storybook. Okay, I used to personally do it before my examinations when I used to prepare for my JEE times. All right, these are like, certain tips probably nobody gives. Okay, so this was really helpful for me. It improved my English also, and it also improved my reading ability, because it is of prime importance, because time is of prime importance in the examination. I hope you understand that. Okay, chalo, let's go ahead and look at this particular question. It says, there is an excited He+, that is a singly ionized helium atom. See, helium atom has got what? 2 electrons. You take out 1 electron, it has got 1. So this is going to obey the Bohr's quantum, like, the Bohr's atomic structure. All right. So here I have got He+ ion, which emits like 2 photons in succession. Okay. It emits like 2 photons in succession with wavelengths given to me as 108.5 nanometer and 30.4 nanometer. So 2 photons, 2 wavelengths, that has been given to me. The quantum number n corresponding to initial excited state. See what is happening? 2 photons. So it is coming from, let me explain to you the scenario and probably we'll discuss about it, okay, later down the line. So see here, the first photon, so the photon was like, the light that coming out. So the electron jumped from, I don't know which state it is. It is at n is equals to, let's say, some x state, okay. And it jumped from n equals to x to n equals to y. This is also something which we don't know. But when this transition actually took place, it emitted a photon which had a wavelength of 108.5 nanometer. Clear enough? Acha. Next, what happened? It jumped from n equals to y to ground state. So we know for ground state n is equals to 1. And the photon which got emitted had a wavelength of 30.4 nanometer. Clear enough? Now, what is the question that is being asked is, tell us the value of your x. What was the initial excited state, right? So what is the formula I'm going to use for this? I'm going to use this formula out here, that is delta E is equals to 1240 electron volt nanometer divided by lambda, and probably I'll take this lambda in terms of nanometer. Okay, chalo, let's go ahead and discuss this. Now, from that formula, we saw that when that electron is actually jumping from n equals to x to n equals to y, all right, when it is jumping from n equals to x to n equals to y, there will be some energy transition. We can give it by this particular formula, 1240 divided by lambda, right? But lambda was equal to what? 108.5 electron volt. Acha. Similarly, delta E2 is 1240 divided by 30.4. Now, this is where? This is from n equals to y to n equals to 1. All right, very good. So that gives me the value of delta E1 is equals to 11.42 and delta E2 is equals to 40.78. Now let us try and understand. See, whenever there is an electron transition taking place in a Bohr's Bohr atomic structure, all right, the formula that we use for the energy absorbed or released, all right, is equal to 13.6 Z square 1 by N1 square minus 1 by N2 square. Now, what is this particular element that we have taken? We have taken helium. And what is the atomic number of helium? It is equals to 2. All right. So here the value of Z will be equals to Z square will be equals to how much? 4. All right. Very nice. Now, that means I can write down E is equals to 13.6 into 4 into 1 by N1 square minus 1 by N2 square. All right. Acha. Now, this entire thing is equal to 40.78. 40.78 in the second scenario, Y21, Y2 ground state. And this is equal to 11.42 from X to Y. That is the first transition. Okay. So, we will try to see this from X to Y. It is equal to the first one. All right, but we are looking at the second one right now. That is from Y to 1. Okay, from N equals to Y to N equals to 1. What was the value? 40.8 will be equal to, this was the energy transition from here to here. So this can be equated to what? 13.6 into 4 into 1 by N1 square minus 1 by N2 square. Acha, very nice. So what can we write the value of this? Like, I took this 4 out here. So this is 13.6 into 1 by Y square. Acha. Now let me tell you why did I do this particular thing. The idea is like very, very simple. What is the simple thing out here? See, this formula right now what you have is for a hydrogen atom. It is, this energy transition is for a hydrogen atom and value came out to be what? 10.2. Now, why am I doing this? The reason behind that is, if you solve this particular equation, you will first have to divide and then you have to take it to this side. Then it will be like, square root of the value. Let me tell you, if you do all these mathematical operations in the examination, if you do all these operations in the examination, tell me how much of your time is going to just wash away. Your valuable time is going to get washed away during the JEE mains examination. Quite a lot. Okay. But what I suggest to all my students is to remember this particular diagram. This is important that certain things you must memorize or keep it in your mind so that you can really act fast in the examination time. Okay, at least for N equals to 1, you should know the value, the energy level. For N equals to 2, you should know the energy level for this and this. Now see, this transition, we got it the value as what? 10.2 for a hydrogen atom, right? Now this is the chart. This is the chart for hydrogen atom itself. Okay, so equivalent to the hydrogen atom, 10.2 is the jump from 1 to 2 or from 2 to 1. So I know clearly what will be the value of Y. The value of Y will be equal to 2. All right. Acha. Now let's do the same thing for the first transition, that N equals to X. Okay, N equals to X to N equals to Y. Now we know the value of Y is 2. So I put down 1 by 2 square minus 1 by X square. Now this is the transition in a hydrogen atom. And how much is this value come out to? 2.85. Now this is from X to 2. Now what do? Should I solve this particular thing? If I happen to solve this particular thing, it is again going to take a lot of time. All right. But if you look at the value, like let's say it's like, minus 3.4. All right. Minus 3.4 and the energy is what? 2.85 for the transition that is there. So which value do you think? See, 3.4 minus 0.85 will be approximately equals to 2.8. All right. So you know the value of Y, value of X in this case will be equal to 4 without even happen to solve this particular equation. So that is going to save a lot of time of yours in the examination. Remember that. Okay. Chalo, let's have a look at the next question. So this is a golden piece of advice. That chart is very, very important. So if you have to do questions faster in the examination hall, you must memorize that particular chart. All right. Chalo, let's have a look at this question now. We'll learn something new in each and every question. So overall, the entire atomic structure is going to be covered by the end of the session. That is, all the formulas are going to be revised. All the concepts are definitely going to be revised through the questions in our today's session. So what do you have to do? Students, go ahead, like the button. Come on, press the like button. immediately and share it as much as possible. Share it in your groups, share it in your your study groups, your WhatsApp groups, your Telegram groups, maybe your Facebook account as well, okay, so that it reaches out to as many people as possible, because we make a lot of effort. Lot of effort is taken in order to prepare even a single lecture for your YouTube sessions. Okay, chalo guys, let's move ahead to this particular question here, and pressing the like and sharing is just your way of supporting us. All right, so in this question, what do we have? We have got a lithium plus plus. That is a doubly ionized lithium atom. That means 2 electrons has been washed away. Okay, so how many electrons does it have? It has got 1 electron, so it is like a hydrogen-like atom. Okay, so here electron in the first Bohr orbit is excited to a level by a radiation of lambda. So there was a radiation, okay, and due to this radiation, the electron kind of jumped, okay, to a excited state. It jumped to a excited state. Now, when the ion gets de-excited to the ground state, in all possible ways, there is a total of 6 spectral lines. Okay, so they have asked us what is the value of lambda. Now, here for 6 spectral lines, what is the possibility? See, if it had actually been jumped to 2, there would be just 1 spectral line, because from 2 it will only come to 1. From 2 it will not go to 3. All right, because now there is an emission. Emission takes place when it is coming from a higher level to a lower level. So it is definitely not going to a higher level. Say it was at 3, then it would have come from 3 to 2, 3 to 1, and then again from 2 to 1. So there will be how many? 3 spectral lines. Similarly, if it was at 4, that's when we see that there are going to be like 6 spectral lines. All right. But let me say if it was having, let's say they told you, say it had some 12 or say 16 spectral lines, probably we will not draw all that, right? So there is a specific formula in order to find out the relation between the energy level and the number of spectral lines. So I hope the question is very clear. There is lithium 2 plus, it was excited first, and from that excited by a particular lambda, it got excited, and from that excited level it started coming down. Okay, and in the process of coming down, it had emitted 6 spectral lines. Okay, 6 spectral lines. Clear enough? Now they are asking us what is the value of this lambda. Okay, chalo, let's go ahead and find it out. No problem at all. So we are going to use this chart once again. How exactly? Let's see. See, the total number of spectral lines is usually given by n into n plus 1 divided by 2. So here if it is 6, all right, you solve it. 6 into 2 will be 12. So here I can see that it is 4 n into n minus 1. There is a small mistake here. There is a small mistake here. Please correct it. All right. This is not n plus 1. This is going to be n minus 1. So let me just write it down for you. The number of spectral lines is equal to n into n minus 1 divided by 2. All right. So this is a small correction out here. Okay. So what do we see here? If it is 6, if it is equal to 6, all right. So that means I'll have my n into n minus 1 will be equal to 12. Very simple. All right. So how do I get 12? How do I get 12? 4 into 3 is 12. Right. So because it is the product of 2 consecutive numbers, and the 2 consecutive numbers that we have is 4 and 3. So the value of n comes out to be equal to 4. So I hope everybody has understood this. Okay. Chalo, let's go ahead and try to understand how to find out the value of your lambda here. Okay. Now we know it initially went from ground state to n equals to 4. From ground state to n equals to 4. So how much has been the energy transition in this particular case? All right. See, the energy, if you go ahead and go back and see this, all right, you have to find out what? You have to find out the value of your lambda. Clear? And how many spectral lines? 6 spectral lines. For that, the value of n came out to be how much? N came out to be equal to 4. All right. And it came from where? It came from, it actually was initially at this particular level, and it went to this particular level. And when it came back, the amount of energy it is going to give out will be equal to how much? It's very, very clear. See, if it is coming from 4 to 1, the energy that is going to be emitted for a hydrogen atom is 12.8. Idea is clear. Okay, see how helpful is this particular chart, right? This is for a hydrogen atom, but we know that the energy emitted will be proportional to z square also. So what is the element that we are taking? We are taking lithium plus plus, hai na bacha? We are taking what? Lithium plus plus. And what is the atomic number of lithium? Atomic number of lithium is actually equal to what? 3. All right. So z square will be equal to how much? 9. Now I know 13.6 into 1 by n1 square minus 1 by n2 square is 12.8. Okay. So right now delta E is 12.8. So what is the energy in this situation must have taken place? 12.8 into 9. Right. Now question became very simple. Right? So we know 1240 divided by lambda is equals to the change in energy. So whatever is the energy exchange that must have taken place out here. So what I can do, lambda can be equals to 1240 divided by 12.8 into 9. If you solve this, you will get your answer as 10.8, and this is your option. Let's see which option is this. This is actually option C. All right, is this clear to everyone? Fine. Chalo, let's go ahead. So just try and understand the amount of effort that we put into it. Okay. Because all the questions, if you look at the solution, it has been broken down into finer elements. It's not like we are scribbling something on one page itself and giving you the solution. So I hope that is going to be very, very clear, so that the student doesn't have to struggle through the scribble lines to make out finally what was the answer later down the line. So it has been very well structured. The solution has been very well structured, and wherever there are proper charts required, it has been embedded. Wherever there is a proper diagram for your understanding, it has been used. All right. So what is our expectation from your end? You go ahead and press the like button. All right. Chalo, let's move ahead to the next question. So what do we have here in the next question? Something interesting? Yes. See, JEE mains again. Okay, what do we have here? See, there is a particle of mass m which moves in a circular orbit in a central potential field, right? That is U equals to half kr square. So I don't know anything else in this question. Only thing that is given to me, we have a potential field of electrostatic nature. Force. All right. If the nature of the force is electrostatic, then we know the potential energy is something else. It is kz e square upon r. That is the distance between the nucleus and the electron. But here, the nature of the potential energy is something different out here. It is U equals to half kr square, isn't it? Now, in Bohr's quantization conditions are applied. So, the Bohr's quantization. What is Bohr's quantization, by the way? See, it's very simple. It says that mvr is equal to nh upon 2 pi. This is called as your Bohr's quantization, right? Now, if this has been applied, then we need to find out that how is the radius and the energy level, okay, is proportional to the quantum number. Clear? So, how is r proportional to n, and how is E proportional to n? Right? See, if the standard case was considered, so what is the standard case? See, the standard case is the nature of the force is electrostatic. So if the nature of the force is electrostatic, this electrostatic force, so this is the electron which is revolving around the nucleus. Okay. Now this provides it with the necessary centripetal force. So this is the centripetal force. So when you combine this with this quantization, Bohr's quantization, mvr is equals to nh upon 2 pi, and you combine them, you get the relation like that r is proportional to n and energy is inversely proportional to n square, right? But that is not the situation here. They have given to us the potential energy to be half kr square. So here the situation is different. The force is not electrostatic in nature. The force is something else maybe. All right. So we know that force, we have studied it in which chapter? Work energy theorem. Okay. In that particular chapter, work power energy, we know force is equal to du by dr for all conservative forces. All right. For all conservative forces, we can define a potential field, and according to the potential field, du by dr will be equal to that force. All right. Now, simple idea. If you actually go ahead and differentiate this, what are you going to get? You're going to get simply kr, right? You're only going to get simply kr. Now, what do? You move ahead and equate that Kr is the force. This is the necessary force which is acting as the centripetal force out here. So the centripetal force mv square upon r will be equal to Kr. Simple idea. All right. Acha, chalo, very nice. So what do we see in this particular equation? You bring this r to the numerator on this side. So v square, you see, will become proportional to what? R square. Very nice, very simple. Okay. So if I combine it with mvr is equals to nh upon 2 pi. This is the quantization, this thing. Okay. Quantization. All right. So this is the quantization formula that we have. And it's a very standard formula. You're supposed to remember this. Very important formula for atomic structure. There's definitely one question which has been asked where this formula will be used. Okay. So now see here. V square is proportional to R square. So obviously V is proportional to R, isn't it? That's a simple thing. Okay. Now here you understand that V is there and R is there and N is there. So these are variables, right? H upon 2 pi is a constant, N is a constant. V is proportional to R, right? So can I say that my R square, like, V is proportional to R. So that makes me my left hand side to be equals to R square will be proportional to what? N. Is this clear? So what should be R proportional to? The R will be proportional to, in that case, root of N. The idea is very clear. All right. Now what we will do, we'll go ahead and see velocity. Velocity is proportional to what? See, try and understand. So velocity we have seen is proportional to, velocity square is proportional to R square. So velocity is going to be proportional to what? Velocity will be proportional to R. Now we know R is proportional to root N. The idea is clear. Now energy is proportional to what? It is proportional to V square, because here V is proportional to R and R is proportional to root N and energy is proportional to V square. So energy will also be proportional to R square, and R is proportional to what? Root N. That means E will be proportional to what? E will be proportional to simply N. That's it. That is root N square. So that will be proportional to N. The idea is very clear. Chalo, let's go ahead to our next question. What do we have in our next question? See, now here, sometimes students tend to make a mistake here, but let's see one question which will help you understand everything about the energy aspects. All right. So what does this question have? There is an electron. Okay. Wow. Very nice. There is an electron. It makes a transition from an excited state to the ground state of a hydrogen-like atom. So they are asking what all things are going to change: kinetic energy, potential energy, and total energy. All three are changing here. Here kinetic energy decreases, potential energy increases, but total energy remains the same. So there is a variety of options which are given to me out here. Now for this, I need to know the expressions for potential energy, kinetic energy, and total energy, obviously. All right, if I have to take a call, or else I can do it by a little common sense also. Now, if I am talking about if I have to do it by little common sense, then how do I do it? Okay, let's try to see it. See, the vague format, it's not that anything will come from nothing. All right, you at least need to know little bit. All right, you need to know a little bit about how things work in this particular area. All right, now let's try and understand this particular question here. See, there was this electron here, isn't it? There was this electron out here, and I think you're not able to see it. You're not able to see it. Okay, chalo, let me just try to get things into your vision. Fine enough. So now you can see this. All right. Now here, if you can see this electron out here, it has been attracted by what? The nucleus. All right. Very nice. If it has been attracted by the nucleus, we know the necessary force of attraction between the electron and the nucleus, that is K, Ze, that is the total charge in the nucleus. Ze is the charge in the nucleus. E is the charge of this electron here. And R is the distance. This is the distance R out here. So this is providing it the necessary centripetal force. Now let's do one thing. Let's deduct this. Okay. So this is mv square is equals to kze square upon R. So just divide this by 2 and divide this by 2. So what do you get? K equals to half mv square, isn't it? So that is the kinetic energy, that will be equals to kze square upon 2R. Simple idea. Okay. Acha, you got the value of what? Kinetic energy. Okay. Now, what do you see the potential energy as? Kze square upon R. right? So here K is ZE square upon 2R, positive. All right, positive. Potential energy is what? This has got a positive charge. Electron has got a negative charge. So the product of the charges is going to be equal to negative out here, right? And it will be equal to K Q1 Q2 upon R, isn't it? So K Z E square upon R. Total is going to be equal to what? Add these two up. All right, so you are going to get this. Acha, by the way, simple idea. Remember one thing, this is positive. This is positive because it is always proportional to what? E square. Or so this is proportional to V square, right? And velocity, when you square it up, you are going to get a positive value, and mass is always positive. Fine. Charges, when they are of negative, so it's going to be negative, right? So this is going to be negative always. All right. And this is also negative. Remember this. All right. Acha. Now let us kind of acha. So we have got three formulas out here. What we remembered very importantly, this is positive, this is negative, and this is negative. All right, this is positive, and the other one is equal to what? Negative. Simple बात है बच्चों. अभी क्या करने का है? ठीक है. देखो, आपको यहाँ पे एक simple understanding ये लेनी है. This is positive, and whatever is happening to kinetic energy, just exactly the opposite is going to happen to the potential, and the total energy. Okay? So let me see any of the options. Does it say like that? Look at the last option. Kinetic energy is increasing. All right. So kinetic is taking a different route, and potential and total is taking a different route. So both of them are decreasing. All right. It is going from a excited state to the ground state. That is of low significance out here. All right. See, one thing is sure, what is going to happen is that whatever happens to kinetic, just the opposite will happen to potential and total energy, because they are with the negative sign and this is with the positive sign. Okay. So when you read out this particular statement, it becomes very, very clear that option D is the correct answer. Acha, by the way, simple idea. See, try and observe also one more thing here. That is, the magnitude of the kinetic energy is equal to the magnitude of the total energy. Try to remember this. It is usually very, very helpful in the examination time when you take this data with you people. All right. Chalo, I think we'll go ahead to the next question. All right. So what do we have in this question? Let's see this. We have got a hydrogen. All right. Chalo. Let's see. We've got a hydrogen, we've got a deuterium. Deuterium is an isotope of hydrogen. All right. And we've got a singly ionized helium. So that is He42 plus. And we have got a doubly ionized lithium. That is your Li83 plus. Because 2 electrons has gone away, it has got only one single electron in the outermost orbit, just like a hydrogen, it is roaming around. Okay. Now, because we know the Bohr's principle, or Bohr's postulates are only applicable to hydrogen-like atoms. Now, what do we mean by hydrogen-like atoms? It means simply the same one thing. That is, there should be one electron rotating in the outermost shell, right? That is like a hydrogen atom. So we will have to always take like doubly ionized lithium, singly ionized helium. So these are all standard things. There is nothing new in any of the questions. All right. Acha. Now they are saying that there is a transition. Now all these electrons are rotating around the nucleus, and the transition which is actually taking place, it is taking place from n equals to 2 to n equals to 1. So that is a transition which is taking place. All right. Now if the wavelengths of the emitted radiations are lambda 1, lambda 2, lambda 3 and lambda 4, that means lambda 1 is for hydrogen, है ना? Lambda 1 is for hydrogen, lambda 2 is for deuterium, lambda 3 is for singly ionized helium, and doubly ionized lithium के लिए क्या है? Lambda 4. So what we need to find out is the correct relation out here. अरे यार, this is such a simple question. I'll tell you how. Okay. See, I've given you the understanding. This is, let's say, hydrogen, helium, deuterium, and lithium. Now, lambda we know comes from this formula. 1 divided by lambda is equals to R, Rydberg's constant. This is what? This is my Rydberg's constant into z square into 1 by n1 square minus 1 by n2 square. All right. Now try and see the transition everywhere is from n equals to 2 to n equals to 1. All right. Here also the transition is from 2 to 1. Here also the transition is from 2 to 1. And here also the transition is from 2 to 1. Simple idea. So this value is going to be the same for everyone, isn't it? Now R is a constant. So what do we observe here? Okay, what do we observe here? Tell me. That is, the value of lambda is inversely proportional to what? Z square, right? Now what is this Z? What is this Z? This is my atomic number, all right? So just we are trying to do is analyze the entire thing. This is what? This is my atomic number. Acha, very nice. See, hydrogen has got atomic number of 1, and deuterium, see, this is going to be 2. I'm really sorry. This is going to be 2 and this is going to be 1. Okay. So this is also got a atomic number of 1. That means what? That the lambda in this case, call it lambda 1 and lambda 2, the values are going to be the same. That means lambda 1 will be equal to lambda 2. Chalo, let's go ahead and see my options. That is there any option of that sort? Yes. Option C. That's it. You have to do only the solving till here. Rest, these are not applicable. These are not applicable. So where you use a smart method, you can save all the time. So you don't need to find out the relation between all the 4 lambda. See, if you look at the question at the first shot, maybe it appears to be that way. But that is the speciality of all the JEE mains questions. All right. That is that there is going to be some, like, it's like a lock and key thing. Okay. So you go ahead and try out that lock and you find out the master key. All right. You will get your answer correct. Okay, what do I mean by the master key? There will be some trick, some hidden concept, all right, which will help you to solve that question in a very faster manner. So you should look out for these clues when you're solving. So keep your minds open. Yeah, don't be stressed. Okay, question nahi ho rahe hain. The question is not being able to be solved. Okay, so what do we do next? All right, don't get into that panic mode in the examination, because whenever you are into a panic mode, first of all your potential decreases tremendously. All right, your potential decreases tremendously. So yaar, why to even lose out on your smartness and IQ just by being panicked? See, whatever you have prepared in the last 2 years, that is going to be like, solid. I mean, like, that if you have prepared less, that's what you will be able to do. If you have prepared more, that is exactly what you will be able to do. So the panic is going to spoil everything. See, smarter methods is what actually differentiates the good students from the average students. All right, remember this particular idea. Acha, chalo students, let's go ahead to the next problem. Okay, now here what do we have? Something really interesting. So these questions are all previous years JEE mains and screening examinations. Okay, so what do we have here? We have got a hydrogen atom and a lithium 2+. So this is my hydrogen. Okay, mass number is 1 and atomic number is also 1. Lithium we have just seen, mass number is 8 and the atomic number is 3. Clear? Now if LH and Li are their respective electronic angular momenta, matlab angular momentum, that's it. Okay, and EH and ELI are their respective energies. Fine enough. Energy we are aware of. We are also aware of electronic angular momenta. That is your angular momentum. Acha bacho, you know one thing, that simple idea is that angular momentum is equals to what? MVR. Right. Now we need to find out the relation between their angular momentum and the energies actually. All right. So try and see here. We know that this is equal to NH upon 2 pi, because see, this is what? Lithium, isn't it? Lithium 2+. So if it is lithium 2+, it is going to obey Bohr's postulates. Now as per your Bohr's postulates, the quantization is kind of true. So as per the quantization, angular momentum is what? Directly proportional to what? It is, it's just a second. There is a little bit of a presentation error that took place. So just excuse me for that. All right. So what do we see here? Angular momentum is directly proportional to N. Simple idea. So in both hydrogen and the lithium plus that we saw here, lithium plus, it is in which state? It is in the second excited state. The value of N is same for them. That means the angular momentum of hydrogen and the angular momentum of lithium is going to be the same. All right. So either this could be true or this could be true. Option A and option B is definitely wrong. All right. Acha, now what is the next thing? What is the next thing? The next thing is simple. The next thing is to find out about the energies. Now, energy we know. All right. energy we know will be directly proportional to, all right, z square, right? We have that formula, E is equals to 13.6 z square upon n square, right? So n is same for both of them. So if n is same for both of them, then energy depends on what? Upon their atomic number. Now, in which case is the atomic number greater? Obviously, it is greater in case of lithium, because here it is 3 and here the value of Z is equals to 1. So option B will be the correct answer. I hope everybody gets it. Simple enough, isn't it? All easy questions, right? Chalo, let's go ahead to the next question. Now, in the next question, it is all about the Balmer, Paschen, Brackett, Fund, Lyman, all those series that has been talked about here. Okay, so what is the question here? See, it says that there is a wavelength of the first spectral line in the Balmer series, right? I hope everybody knows what is the Balmer series. If you don't know, I've got a very nice diagram to show it to you. Okay, so we have said that in the Balmer series, the first spectral line, and its a wavelength has been given to you. All right. So what is the wavelength? 6561 angstrom. Clear enough? Acha, they've asked us the wavelength of the second spectral line in the Balmer series. Right. That's a simple question, isn't it? How do you do it? Now, in the Balmer series, try and understand see, I'll tell you. See, the wavelength is given by this formula here. 1 divided by lambda rz square into 1 by n1 square minus n2 square. So when I'm talking about the Balmer series, all right, what is the value of n1? So all of them actually starts from n is equals to 2. See, this is what? N is equals to 1 and this is n is equals to 2. So this value of n1 will be 2 for all the lines. So if I am talking about, all right, the first line, the value of my n1 will be 2 and the value of my n2 will be equal to what? 3, right? So for that, the value of 1 by lambda 1 will be equals to r into 1 divided by 4 minus 1 divided by 9. If you solve it, you will get 5r by 36. You will take 9 into 4, 36 as the LCM and you will get 5r by 36. Similarly, if you take the second line, now about the second line, what is it? N1 will always be equals to 2 because it's the Balmer line. Again, the second line of the Balmer series, that's what has been asked. The second spectral line in the Balmer series, so N1 will be equal to 2. So second wale ke liye, what happens is the value of N2 is equal to how much? N2 is equal to 4. Simple idea. Okay. So what do you get? The value of 1 divided by lambda 2 is equals to r into 1 divided by 4 minus 1 divided by 16. It comes to 3r by 16. Fine enough. Acha. Now 1 divided by lambda 1 is equals to this much. 1 divided by lambda 2 is equals to this much. Simple idea. Just like the first question that we did, lambda 2 by lambda 1 will be equals to 20 divided by 27. And if you put down the values of your lambda 1 here, you will get your answer. Okay? Chalo, let's go ahead to the next question. Acha, now this is a very, very interesting question. Now let's see. This was asked in JEE Mains 2010. Okay. So what is the question? It says that there is a diatomic molecule which has a moment of inertia equals to I. Fine enough. It has a moment of inertia how much? Is equal to I. Arey wow. Rotational concept in atomic structure. Looking at it, some people will say, oh, very tough question. Let's leave it and let's go ahead. But let's see if you can crack it. Definitely you can crack it. It's only about the striking of the thought at the right time, at the right place. All right. See, I'll tell you what happens is students try to learn the formulas for their competitive examinations by heart. But when there is interconnectivity of two concepts, that is where they fail. And JEE Mains actually tests you on that ability of yours. And JEE Advanced will definitely test you on that ability, that you're able to like, get the understanding of the remix of concepts between two different areas. Okay. So one could be like from rotational to atomic structure. If you're able to connect these two things, you're pretty fine. I mean, you will be able to solve the question. Okay. So what does the question say here? It says that I've got a diatomic molecule. Fine enough. You've got a diatomic molecule and it has a moment of inertia equals to how much? It has a moment of inertia equals to I. By Bohr's quantization condition, you know what is Bohr's quantization condition? That is MVR is equals to, that is angular momentum is equals to NH upon 2 pi. Its rotational energy in nth level will be given by which formula? You need to find out the rotational energy. Wow. How do you do it? Interesting, right? Chalo, let's have a look at this. See, we know for sure. Let me just move ahead to the left hand side. Acha. Now, angular momentum we know is I omega. and angular momentum is equals to what? nh upon 2 pi. Now from this formula, you can find out definitely what is equal to your omega, isn't it? What is the value of your omega? You can see here, it is nh upon 2 pi I, because I brought this I to the denominator out here. Okay, areva, simple. Now, omega, if you see from this, okay, h is a constant, 2 pi is a constant. Moment of inertia is fixed for this particular situation. So what is omega proportional to? Omega is proportional to what? N. Areva, very simple. Now, what is energy? Rotational kinetic energy. Rotational energy is half I omega square. So half I omega square, that is the rotational energy. See, omega is proportional to N. So omega square will be proportional to N square. That means energy, rotational energy will also be proportional to N square. So do you see any of the options which is only proportional to N square? Yes, option D is the correct answer. Very smart. You don't have to solve like the entire thing to get the answer. And you can just look at like, the proportionality and get your answer. We have done one previous question also like this. Chalo, very nice. If you're able to understand this. Okay. Chalo, now let's go ahead and look at our last question for today's session. What do we have here? It is found that the excitation frequency from ground to the first excited state of rotation for CO molecule is close to 4 divided by pi into 10 to the power 11 Hertz. Then the moment of inertia of CO molecule about its center of mass will be close to how much? Areva, this is also not very difficult. See, try and understand. From the last question, it's an extension of the last question. Okay, there is a diatomic molecule. So that's what we have taken here. The diatomic molecule is CO in this case. Okay, so what we found out is the value of the energy. Right, it came out to be what? Rotational energy, n square h square upon 8 pi square into I. Clear enough? Now they are saying that it has made a transition. Now the transition is from where? From ground to first excited state. Ground state n is equals to 1. A first excited state n is equals to 2. So that change in energy will be equals to how much? See here, 2 square will become 4, h square upon 8 pi square I minus h square upon 8 pi square I. So if you take this difference, it will be 3h square upon 8 pi square I. Clear enough? Now from here, you know the value of delta E. It has been given to you in the question. Now you bring this I to the numerator and delta E to the denominator. You will get your answer. Simple idea. Okay. Chalo students, that's it for today's session. I hope you enjoyed and liked each and every problem which was kind of really handpicked and chosen enough so that your entire chapter of atomic structure gets well revised. All right, we have covered each and every formula and the application of that particular formula. Okay, so God bless you, all you students. Now, I would like to run you through something really very important when it comes to being connected. I think in these times, and especially these times, right? So we should be all right, very well connected, and that is through this Telegram app. Now, what is this Telegram app? I think everybody is aware of it by now. Okay, so the Telegram app, we have this group out here that is tiny URL. You can just go ahead and select and just be a part of this group. See, look at the total numbers of this particular group, 32,116 members. Okay, 32,116 members, and at a certain time when the snapshot was taken, there were 781 online. So it's like a hub of JEE aspirants, right? So you can discuss anything, whatever thing that comes to your mind, you can discuss those things. You have a certain doubt, you can discuss those particular things, isn't it? You have, let's say, any query, some important news has been out. Say the JEE application date has been, like, obviously we keep you giving updates every now and then, right? But let's say you must have missed out. By some chance, you must have missed out on that particular thing. But this group notification will keep on coming, isn't it? See, if you are subscribed to our channel, even then also you will get it. But let's say if you are not subscribed, let's say there is a hypothetical scenario that you are not subscribed. Okay. So once you are a part of this group, you will always be updated about the latest information. That is the first thing. Okay. Acha. Next thing that I wanted to tell you, which I have already discussed in the beginning of today's session, that is the tinyurl.com/JEE mobile. You will get all the lectures, physics, chemistry, mathematics of 11th and the 12th standard. है ना? ये 11th and 12th, all the lectures, all the topics, all the subjects for 11th and 12th is present out there. So if you have missed out on anything, Arey yaar, this is all what, by the way, I forgot to tell you, this is all free of cost. This is all free of cost. You don't have to pay a single penny for this, okay? You only have to invest time into it, all right? Achha, tell me something, if something is like, so valuable and that also is given free of cost, okay? Tell me something, how much more valuable could be this subscription? All right. See, try and understand the entire ecosystem or the entire space of education is actually changing. Okay. But we are still stuck with the British education system. And that is creating all the problems. See, remember, I used to once upon a time when I was a very small young boy, okay, I used to watch movies in something called as a VCR. You remember that VCR? Some of you must have seen. That is like, an outdated thing. Sometime back, I showed it to my daughter as well, and she was like, "Oh, Dad, what is this particular thing?" I said, "This is an antique piece." Okay, we don't use that anymore. There used to be a huge, big cassette out there. Magnetic tape was there. All right. After that, what happened? When the VCR thing just faded away, there was CD. All right, there was CD, and the CD thing was very, very in thing during my teenage time, specifically like when I was preparing for my JEE mains and advanced. Right, so there was CD, and I usually had like those bunches of like 100 CDs, and I have such three stacks: one for music, one for movies, and one for all kinds of entertainment. Right, now we just share certain things right now, but at that time it used to be just CDs. I used to keep all the ads, funny videos in that collection of miscellaneous videos, right? I had some 100 CDs of those sort. Acha, that time also got over. Then we got what? Hard disks. In our hard disks, we used to store all the movies and keep. And wherever I used to travel, I used to have hard disks. So we slowly evolved, and we went from where? We went from, let's say, 256 GB hard disk to 500 GB hard disk, and then came 1 TB, 2 TB. All right. Acha. By the way, if you want to watch movies these days, what do? You just have a Netflix subscription. You have a Cine Prime subscription. You have a Hotstar subscription, right? See, everything is changing. So is education changing. If you do not realize it right now, your next batch is definitely going to realize, or the batch next to next. So it depends upon you. Okay. So it depends upon you that how fast you are or how adaptable you are with this changing circumstances. All right. Acha. Now, what is the benefit of these Netflix and all of these whatever you call it, like whatever the movie channel subscriptions? You get different genres, you get different kinds of movies, you get different kinds of actors, like you can do the selections. Okay, I want the lectures of, let's say, Shah Rukh Khan, so all Shah Rukh Khan movies come out there. Or let's say you want to do the all thriller movies. You want to, today I'm in a mood of watching thriller Ghost, okay, so all the thriller movies are going to come out there, right? So something very similar with the Unacademy subscription. Okay, so I'll tell you the features. Features is something, okay, fine, you all will know it by somehow or the other. See, try to understand the value. That's what I'm trying to explain to you out here. Now, here in the Unacademy subscription, you get exposure to different faculties. You get exposure to different kinds of courses. You get exposure, all right, to different levels of courses. Now, there is everything for everyone. Now, it's not that there is only for very good students, because sometimes it so happens that when you're into a coaching institute, you have content for good students or for average students. There's nothing for the very low, like someone who wants to learn a thing. Say I was having fun, and then suddenly I just realized that I should be serious in life. Can I rewind time? Can I do time travel? No, I cannot do time travel. I cannot go back to start of class 11 and then like, oh sir, now I'm got serious. Now you please teach me mechanics. Okay, that cannot happen. But with this subscription, you can visit the lectures not once, twice, but as many number of times as possible during your subscription period. Okay, and you can take the maximum benefit. So if you want to attend, let's say, one new course, a live course, all right. So whatever is the prerequisite for that particular course, the teacher would tell you, okay, just go ahead and see those videos of mine and come and attend this particular course. So you are serious. So you will make all that effort to study the backlog and appear live, all right, for the course which is currently going on. So these are some of the benefits that you get from the Unacademy subscription. By the way, something very important for the features of the Unacademy subscription, you get live classes and you can interact directly with the educator. I think it is self-explanatory. We've got live polls and leaderboard. Now, what is with this live polls and leaderboard? See, with the live polls and leaderboard, what happens is the classes become super interesting. You have the top three, and not just the top three are like, competing among each other. All right. It is also like, there will be a very thin line of difference. Maybe from the first to the 10th guy, there is difference of marks of only 2. Only like, the first one could do 2 correctly and he was able to do it faster. So things could change any moment. And then the students are like, all very eagerly, waiting when the next question I'm going to press on the button out there and go above the ladder. All right. So something which is very, like, keeps the class very lively and very active. All right, so you're going to enjoy this particular thing tremendously. We've got the test series and analysis, which keeps happening on a weekly basis. Okay, and the analysis is like super. All right, and then we have got the live doubt clearing sessions. For the live doubt clearing sessions, all you have to do is you've got special sessions, not the lecture sessions, but in the special doubt clearing sessions, you just have to click the photograph and send it right away, and these questions appear, and sir is going to solve your doubts on an instantaneous basis. All right, and have an interaction with you on an on and off basis. Clear? So what I'm trying to say is these features, try and understand. I mean, like, they are like the lifeline of the Unacademy subscription. But besides that, understand the concept behind it. That is like more important. What is the concept? What is the underlying principle out here? Okay, how is it of value to you? See, just making you count 1 or 2 features, that doesn't make something like, super important. But try and understand what is the current circumstances, and under the current circumstances, what is important. Things have changed, things have evolved, life has become faster. I mean, do you manage to see yourself like, you are going for a cricket practice, and or let's say any other particular your skill development thing, and you're also going to a coaching institute, you're going to a school also in the morning. I mean, how much amount of travel is involved in specifically in the cities? All right. So everything is evolving. Everything is, see, new things come up in order to replace the old things. So that's exactly what is happening out here. All right. Chalo, I think that is enough to explain to you what is the value of such kind of a subscription. Okay. Acha, by the way, if you look at these set of educators out here, we have got Namo sir, we have got DC Pandey sir here. Okay. And this is like Namo sir's A team. All right. What you would see is getting the subscription is giving you access not to just one teacher, not just to my lectures or say Namo sir's lectures or to DC Pandey's lectures. There are over 80 plus educators. 80 plus educators on the Unacademy platform. Just imagine, what are you getting? You're getting a gold mine for something which is, you're getting a gold mine for the price of a coal mine. Okay. Well, mines are anyways costly, but like, you're getting gold for the price of coal. Fine. I hope you understand what I'm trying to say here. Acha, moving ahead, let me just explain to you the steps now in order to get to this. See, this Unacademy learning app, you need to search for this. Clear? Go ahead, press the install button. Very simple. Okay. Once you press the install button, you will have to select plus. And once you've selected like plus, all right, once you've selected plus, what you can do is select IIT JEE or NEET UG or foundation. See, whatever is applicable for you. Okay. At different students, different level of students watch my lectures. So I think whoever is the viewer, I mean, whatever is applicable to you, just go ahead for that. And go ahead and press this get subscription button. So once you press on the get subscription button, you will be redirected to this particular page here, where you will see the prices, just a second. Where you will see the prices for 1 month is 6,000, 2 months is 5,000, 3 months is 4,000. This is like, 3 months, 6 months is 4,000 per month. So it becomes 24,000 for 6 months. All right, that way. And for 12 months, it comes to somewhere around 30,000. And for 2 years, it comes to 36,000. So let me just broaden this. It comes to 30,000, 30K and this comes to 36K. All right. Acha. Now something very interesting is, now first of all, these rates are like very low. Just imagine the other coaching institutes which charge you like, a bomb from you. I mean, someone even charges like 3 lakhs, 4 lakhs these days. Okay. In the cities. Now here, further thing is, if you see this value, first of all, it is less. Another thing, I'm giving you a special value. That is, use the code SMLIVE and right away get maximum possible discount, and your rates will come out to 27,000 for 1 year and 32,400 for 2 years. Try and understand these. Okay, it comes to how much? 27,000 for 1 year and 32,400 for 2 years. So if you divide it by the total number of months, it comes to only 1350 per month. Array, the tuition teacher also charges more than this for one subject. The tuition teacher, the local tuition teacher will charge you more than this for one subject. And what is Unacademy giving you? The top educators, the HODs, the authors of this particular country on one particular platform. Acha, I'll tell you another thing. Per day it comes to how much? 50 rupees. Yeah, this is the price. I mean, this is a one cafe coffee day. One cafe coffee day mocha latte is also like, it's a higher 3 times 200 rupees, 4 times 200 rupees. So what I'm trying to emphasize out here is something so valuable comes at a peanut price. Okay, so that's what you need to think. Okay, rest is up to you. All I want to say is this code is super important for all of you. Acha, bachcho, important now is this JEE English channel. Go ahead, subscribe to it immediately. Subscribe to it immediately and press on the bell icon. What happens when you press on the bell? Acha, bachcho, by the way, the ones who are watching me regularly out here, they would know it. But if you're watching me for the first time, okay, spread it to as much students as possible in your friends group, in your community as much as possible. Let it go viral, because something really interesting is coming up on this particular channel in days to come. All right. Acha, bachcho, by the way, if you haven't shared and liked and shared so far, go ahead and like and share it immediately. Immediately. All right. That's what we do. We get something nice, we should share it, right? See, if you are watching it till the end, obviously you have liked it. So share it as much as possible. If I get something good, I would want to share it, isn't it? Acha. Another important thing is this is not just it, JEE English. We have got other channels. NEET, JEE, Foundation. So go ahead and crack. Let's crack it. That's our mantra. Whichever examination you're preparing for, just go ahead and give it your best. And yes, Unacademy, we really care for all of you, and all of our educators put in tremendous amount of effort to give you the best in life. All right. Acha bacho, finally, let me just summarize by telling you that this code is super important, and let's say during the time of buying, you forgot what is the code. I'll teach you one very easy method to remember it. I do it a lot of times, all right, in my teaching as well on the plus. See, SM, it stands for Superman. Superman is my favorite superhero, all right. So that's how that character is also like, in my name as well, all right. SM, Superman, you would definitely remember it. And live, that's what happens when you come to the plus platform. You get access to the live sessions. So Superman live. That's what you are expected to remember. By the way, tomorrow we are going to have a session on photoelectric effects. So take care, bye-bye, and see you tomorrow at the same time. God bless you.